Hello everyone, let's solve some numericals based on Prism. Example 1 says an equilateral prism produces a minimum deviation of 40 degrees. Calculate its refractive index. We know that for a prism n is equal to sine of a plus d by 2 by sine of a by 2. Now in this case, what is given is the angle of minimum deviation, which is capital D, is given as 40 degrees, and also it is an equilateral prism. Remember that for a prism, its cross section would be a triangle. In this case, since the question says it is an equilateral prism, it would mean that all triangles are 60 degrees, out of which one angle, which is the angle between the two refracting faces, was called as angle of prism, and that was called as A. So in this case, this A is equal to 60 degrees. So n is equal to sine of 40 plus 60 by 2 by sine of 60 by 2. This is equal to sine 50 degrees by sine of 30 degrees. Sine 50 degrees is equal to 0.7660 by half. Because sine 30 is half, this 2 goes on top. Therefore, n is equal to 0.7660 into 2 is equal to 1.532. So, the refractive index of the prism is 1.532. Example 2 says a ray of light incident at 60 degrees on a prism undergoes a deviation. It is just deviation, not minimum deviation. So, a ray of light incident at 60 degrees on a prism undergoes a deviation of 20 degrees. Show that the emergent ray is normal to the second face of the prism. Recall that for a prism, we define few angles. So suppose if this is the prism's cross section, let's call this as point P, point Q, and this is point R, and the angle here is angle of prism A. If light ray falls on this face, the angle which this light ray makes with a normal, this is called as I1. Light refracts, and if we draw normal at this point, this angle was called as R1, and the angle made here was called as R2. Light ray would emerge out finally, and the angle made here was called as angle of emergence, which is I2. So question says show that the emergent ray is normal to the second face. It's not drawn normally here, but then we need to prove that the emergent ray, that is this ray, is normal to the second face. In that case, it would be a TIR because light would come out like this. Now here, delta is given as 40 degrees, and a light ray is incident at 60 degrees, which means I1 is equal to 60 degrees. Now here deviation is not 40 because it is angle of prism. So basically here A is equal to 40 degrees, and deviation here the deviation is equal to 20 degrees. So we know that delta is equal to I1 plus I2 minus of R1 plus R2. Delta is equal to I1 is 60 degrees plus I2 is unknown minus R1 plus R2 is nothing but angle of prism A, which is equal to 40 degrees, and delta itself is given as 20 degrees. So from here we find out that 20 is equal to I2 plus 20, because 60 minus 40 is 20. This would imply that I2 is equal to 0 degrees. When I2 is 0 means the light ray would come out normal to the surface, because this is 0. It is normal to the surface. Example 3 says the angle of a prism is capital A. One of its refracting surface is silvered. Silvered would mean that the light ray would reflect. Light rays falling at an angle of incidence 2A on the first phase returns back through the same path after suffering reflection at the silvered phase. So it says that the light falls on the second phase, which is silvered. The light would retrace a path. We learned that in case of a mirror, whenever light falls normally to the mirror, the light would retrace its path. It would come out like this. So what is given here is, it says that the light ray returns, which means the light ray falls normally on the second surface. So in this case, question says find the refractive index of prism. So let's try to draw this diagram. If you assume that we take a let's call this point as point P, point Q, this point R. It is given that one face is silvered. Let's assume that this face is silvered. The question says the light refracts on the first surface and then return back through the same path after suffering reflection. Whenever light ray falls normally, it will undergo change its path and it would retrace its path. So if light ray falls like this, it refracts here, and light ray would fall normally on this face such that this is normal. Light ray would retrace the path. Let's draw it a little differently here. If we draw normal somewhere here, for example, at this point, light rays fall normally on this face. So when light ray falls normally on this face, it would retrace its path. So if light ray falls at an angle here like this, light undergoes deviation, falls normally and comes back. So if say BC is incident ray and this CE is the refracted ray, since the light ray falls normally, it will retrace the path. Question says find the refractive index of prism. Now we know that for a prism, if this is angle deviation A and this angle is given as 2A, this is 2A. If you assume that the light moves from A to the prism, then using Snell's law for the surface PQ, we get 1, because the refractive index of air is 1. 1 into sine 2A is equal to n into P, or just write n into sine the angle made here. If this is R1, it becomes sine of R1. If light ray was normally on the prism, in this case R2 would be 0. Recall that A is equal to R1 plus R2. Since R2 is 0, then A is same as R1. So A is angle of prism. Therefore, from here, A is equal to R1 only because R2 is 0. So what we get here is sine 2A is equal to n of sine into A. Recall that sine 2A is nothing but 2 sine A into cos A. So this becomes 2 sine A into cos A is equal to n of sine A. From this term, sine A gets cancelled. Therefore, what remains would be n is equal to 2 times cos A. So this is the refractive index of the prism. Example 4 says a ray of light is incident normally on one of the refracting surfaces of a prism of refractive angle 60 degrees. So for a prism, the angle of refraction, which is given as A, this A is given as 60 degrees. Question says the emergent ray graces the refracting surface. Find the refractive index of prism. So let's draw a diagram quickly for this. If we draw a prism's cross section, if this is point P, point Q, point R, if light falls on any one face, on this face like this, the angle made here is I1. Light refracts. This angle is R1 and this would be R2. Question says the emergent ray graces the other reflecting surface, which means the light ray which is emergent at this surface, it would grace. Grace means it would move along the surface, moves like this. That means that the angle made here, which was called as angle of emergence I2, in this case I2 is equal to 90 degrees because the light ray moves along the surface. So question says find the refractive index of the prism. But what is given in the first cases, it says the light ray is incident normally on the one refracting surface, which means here light ray was normally only. So even here in this case, if light ray was normally, then I1 is equal to 0 degrees because light ray was normally. It's not seen visible here, but think of a case like this where it was normal like this. So in that case, I1 would be 0. When light ray falls normally, this light ray is undeviated, which means the angle made here also would be 0, which is I2, which is R1. So even R1 also is equal to 0 degrees. So if you use Snell's law at the surface PR, if assuming the prism's refractive index to be n, then n into sine R2 is equal to just 1 because I2 is 90, sine 90 is 1, or I'll write it here into sine 90. So n into sine R2, let's recall that A is equal to R1 plus R2. Now since R1 is 0, then A is same as R2 only. Now what is given here is the refractive angle of prism is 60 degrees, which means R2 is 60. So is equal to 1, n into root 3 by 2 is equal to 1, because sine 60 is root 3 by 2. N is equal to 2 by root 3. 2 by root 3 is 1.732. Therefore, n is equal to 1.155. This is the required Prism's refractive index.